Welcome to Mathematics and Statistics, Matrices, Chapter 2, second part of this series. Class 12, Commerce, Mastering with PYK. In this series, we'll talk about Exercise 2.1 and revise the concepts we learnt in the previous part, that is Part 2.0. So let's start Exercise 2.1. Question 1. We have to construct a matrix, that is A, such that Aij is 3 cross 2. This means we have been given the order of the matrix as 3 by 2 and the elements represented as Aij given by, we have 3 parts, 1, 2 and 3. So here Aij is defined as I less j square divided by 5 minus I. So we need to find out each element of a matrix represented with Aij. So we will have to find A11, A12 and so on till we get the order of 3 cross 2. So let's understand what does it mean. It means that A is a matrix, I represents rows and J represents column. Order of the matrix is 3 cross 2. This means we have 3 rows. So when we say 3 rows, we have A1, A2 and A3. That is, the I would range from 1 to 3. So this is our rows. And we have 2 columns. So J would change from 1 to 2. So we'll have a matrix which will have 3 rows and 2 columns. So number of elements in the rows in the matrix would be 6. So let's solve. Question number 1. Please do it yourself. I'll start with second. So Aij is represented as I less 3j. So let's start representing I and j and the required Aij. So we know that we have 3 rows and 2 columns. So I would vary till 3 and rows would vary 2. So let's start. I as 1, 1. So when I is 1, j is 1, our element would be A11. Putting in the values, we get 1 less 3 multiply 1, that comes out to be minus 2. Similarly, we have A1 and J2. This means we are talking about the element in the second column. So we have element in the second column here. Putting the values, we get I as 1 less 3 multiplied 2, that is j is 2 now. We get 1 less 6, which comes out to be minus 5. In the second row, we have I as, here we are. So I is second, column is 1. Our element becomes A21. So I less 3 multiply 1, which comes out to be minus 1. And A22. This means we are here, second row, second column would be I, that is 2 less 3 multiplied 2, which comes out to be 6. So 2 less 6 will be minus 4. The third row, now we are here. So 3 and 1, this is the first column and this is the second column. So first column, third row, so it is A31. A31 would be 3 less 3 multiply 1, which is 3 less 3, that comes out to be 0. And A34 second column would be 3 less 3 multiplied 2, which comes out to be minus 3. So the required answer would be, so the required matrix is, putting the values in the matrix form, we had 3 rows, 1, 2 and 3 and 2 columns. So A11 is minus 2, A12 is minus 5, A21, that is second row, first column is minus 1, second row, second column is minus 4, third row, first column is 0, and so we have third row, first column is 0, and third row, second column is minus 3. So this is the required matrix. This means we are representing a matrix with the elements that has to be found with a equation. Right? So the question 3, that is Aij, that is elements are represented as I plus j cube divide 5. So we know that we need 6 elements because it is 3 cross 2, that is 3 rows, 2 columns. So it comes out to be 6 elements. So let's start. First row, we will have I1, J1. Putting the values, A11 would be 1 plus 1 cube upon 5. So it is 2 cube. 2 by 2 multiplied by 2, which comes out to be 8 by 5. The first row and the second column, that is A1, 2. So this is A1, 2. Putting the values, 1 plus 2 cube by 5. So 1 plus 2 is 3. 3 cube is 3 multiplied 3 multiplied 3. That is 3 3s are 9, 9 3s are 27, divide 5. Going to the next row. So we are here now. It is second row, first column, A21. So I becomes 2, J becomes 1. It is 2 plus 1 cube by 5. We did it up. So it is 3 multiplied 3 multiplied 3 comes out to be 27 by 5. A22. So we are here now. We have 2 plus 2 cube divide 5. So 2 plus 2 is 4. 4 cube is 4 multiply 4. That is 16 multiply 4, 64 by 5. The third row, this position, A31 is third row, first column. So 3 plus 1 cube by 5. 3 plus 1 is 4. 4 cube is 64 by 5. And A32, this means this position, we have 3 third row plus second column, that is 3 plus 2, 5 cube by 5, that is 125 by 5. Right? So the required matrix would be the first one, that is A11 is 8.5, 8 upon 5, A12 is 27 by 5, A21 is 27 by 5, A22 is 64 by 5, A31 is 64 by 5, and A32 is 125 by 5. Now, in this case, you see that all the elements have 1 by 5 as a common. So we can remove 1 by 5, right? The remaining factors in the matrix form. So here 1 by 5 is a constant. It is also known as a scalar or represented as k. This means 1 by 5 gets multiplied by each element of the matrix. Let's revise concepts. This is what we learned in the previous class. Row matrix. So how do we define a row matrix? A row matrix is a matrix that has only one row irrespective of number of columns. So this is an example where the matrix is of the one row. We have 3 columns, right? So the order of the matrix is 1 cross 3. In this, the matrix is of order 1 row and 2 columns. Square matrix is represented where M and N both are equal. So it is 2 cross 2 square matrix. And here it is 3 elements in row, 3 rows and 3 columns. So it is 3 by 3. So we'll have in all 9 elements in this matrix. Column matrix, a matrix having only one column irrespective of number of rows. So here we have one column and 2 rows. So the order of matrix is 2 multiply 1 or 2 cross 1. Here we have 3 rows and the 1 column, so it is 3 cross 1. An identity matrix or a unit matrix denoted by capital I. This means the elements on the diagonal would be 1 each and non-diagonal elements would be 0. And identity matrix should qualify after being a square matrix. So example, first we'll have to check the order of the matrix. So it is 2 by 2. So it is a square matrix and the diagonal elements are 1 and non-diagonal elements are 0. It is denoted by I2 cross 2 or I2. Similarly, we have I4. This means 4 rows, 4 columns. The diagonal elements are 1 and all non-diagonal elements are 0. A zero matrix is also called as null matrix denoted by capital O. Again, it has to be a square matrix with all the elements 0. Here, the diagonal or non-diagonal elements would not differ. So example, we'll start first with the qualification, that is 2 cross 2. So yes, it is a square matrix. Right? I can represent it by any letter which is capital, but generally it is represented by capital O. Right? So here we have 4 cross 4 and all the elements are 0. So it is a 0 or a null matrix. Let's understand some property of a null matrix. When we multiply a matrix with a null matrix, we always get a null matrix. Because when each element is multiplied by 0, say 1 multiplied by 0, the answer would be 0. So irrespective of the matrix A, whenever a matrix is multiplied by a null matrix, the outcome is 0. So it can be null matrix multiply A or a matrix multiply null matrix, the value is 0. A scalar matrix is a diagonal matrix which also has to be a square matrix. Its non-diagonal elements are 0 but its diagonal elements are equal. So a unit matrix is also a scalar matrix with value 1. So example, let's start. First qualification, it's 2 by 2 matrix. So yes, it is a square matrix. And the elements in the diagonal are -3, so they are equal, and the non-diagonal elements are 0. Here, the matrix A, we have 4 cross 4, so it is a square matrix. It is a square matrix, and non-diagonal elements are 0 and diagonal elements are 5. Let's understand transpose of a matrix. A matrix that is obtained by interchanging rows and columns. This means the column here becomes a row a column here becomes a row. So when we interchange the column to row or vice versa, it is called as transpose of a matrix. So the order here was m multiply n. This means row represented by m will become the column when we transpose, and the column would become row. So this is known as transpose of a matrix. So let's understand this with an example. So we have a matrix A represented with elements which is 3 cross 2, and we need to transpose it. So transpose of a matrix is represented as A to the power T or A hyphen or A dash. So here when we transpose, the column would become row, right? So we have first column becoming first row. The elements are 3, so 3 elements would transpose and become -3, 5 and 8. The second column would become a second row, so it is 2, 6, 7 getting transposed as a row. So now the order would change. The column would become row and a row would become a column. So before we proceed, let's understand few properties. When we transpose a transposed matrix, we get back the original matrix. So if we have to transpose it again, so it would become A transpose of transpose. The row here would change to column. So the row here changes to column. This row would change to column. So we get back the original matrix, that is A. And a transpose of addition of two matrices can be separated as A transpose plus B transpose. Multiplication would be, we can divide it, meaning split it. So A transpose multiplied by B transpose. Whenever there is a scalar or a constant factor k, which we learned in the previous slide, so k can be taken common because k being a factor, maybe 2, 3, 4, right? It doesn't change with transpose, right? So it is a common factor. We get it outside the matrix and multiply it by A of transpose, where k is a scalar or called as a constant. So let's understand addition of matrices. How do we add the matrices? If the matrices are of same order, right, then the addition can be defined. If not, addition is not possible. So two matrices have to be of the same order and the resultant would also be of the same order. Example, if Aij with different elements of order 3 cross 2 is to be added with Bij as elements of order 3 cross 2. So the addition here is defined. And A plus B matrix would be equal to C, which will be Cij with the order 3 by 2, similar to the addition of the matrix A and matrix B. Let's understand with example. So we have two matrices A and B. So first we'll start with the order. So order here is 2 rows, 3 columns, 2 rows, 3 columns. So addition is possible. So first we'll check the possibility. So it is possible. So how do we add? We add each element, right, of their positions. So A11 will be added to B11. A12 would get added to the 1, 2. So we get 2 plus minus 4. The second element would get added to 3 plus 3, 1 plus 1 minus 1 would get added to 5, minus 2 would get added to 7, 0 would get added to minus 8, right? So order remains the same. So we have 2 rows and 3 columns. So on solving we get 2 plus minus 4 will be minus 2, 3 plus 3 is 6, 2, 1 plus 1 is 2, minus 1 plus 5 would be 4 positive, minus 2 and 7 would be plus 5, and 8 plus minus 8 would result in minus 8. So order of the resultant matrix is 2 by 3. So this is how we add. So addition exists only when matrices are of same order. So see you in the next part. Keep practicing. Clarity and confidence goes together. So practice hard. Keep practicing. Bye-bye.